Today we are going to dwell one more important topic from business statistic perspective is confidence interval. Whenever we say confidence interval, we tend to think that it applies only to continuous data, that is variable data or anything which you can measure. But however, we can apply to discrete data also as well. Discrete data is also known as attribute data. We can apply. How? Let's go further. How the confidence interval can be calculated. Confidence interval meaning like how the data has been distributed, and we can find out the 5% risk we can have, that is alpha, and then rest other things is that how much points lies in that 95% spectrum. It can be like interval plot, as you can see. It can be in the form of box plot and so on, or commonly used as histogram also as well. So I picked up from this book called Statistic for Manager using Microsoft Excel 7th edition, and there are some examples. So this is an example of the continuous data, and in upcoming slide you will find more details about it. The formula is straightforward: x bar, that is mean, plus or minus m. M is margin of error. That again, if you calculate the margin of error, z times standard deviation divided by square root of n. This is a formula, and then depend upon the z value, like 95% confidence or 99% confidence, different value that we are going to discuss in upcoming videos in detail. And this is how it gets calculated for proportion. Now the confidence interval has this formula, whereas the confidence interval estimate for the proportion is that p, that is proportion, plus or minus margin of error. The margin of error here, there it was z into standard deviation divided by square root of n, but here it goes into z square root of p, that is proportion, 1 minus p. Let's say p value is 10%. You will write 0.1 into 0.9, 1 minus p, divided by n, how much sample you have. This is a formula we can apply. From there, you can easily calculate for discrete also as well. So the discrete or variable has two distinct formulae. And this is how you can calculate if it is the standard error of means, that particularly we're talking about that in the variable, you will write this way, standard deviation by square root of n, but proportion you'll write this way. And you can apply this one in Excel also as well. In upcoming video, we'll talk about it, and this is how we can apply it. For example, let's say this is an example where the length have to be found out, newspaper example, and between 13 to 22% defect we have. The average defect is 17.5%. And this is a good example, both in one single slide. And this is the